Solubility curves. Objectives. Distinguish between unsaturated, saturated, and supersaturated solutions. Classify solutions as unsaturated, saturated, and supersaturated using a solubility curve. Distinguish between solubility curves of solids and gaseous solutes. And finally, to interpret solubility curves. What are unsaturated, saturated, and supersaturated solutions? Solubility describes the amount of solute that can dissolve in a given amount of solvent. An unsaturated solution contains less than the maximum amount of solute that can be dissolved at a given water temperature. It can dissolve additional solute. A saturated solution contains the maximum amount of solute that can be dissolved in water at a given temperature. If additional solute is added, it will not dissolve. A supersaturated solution contains more than a maximum amount of solute that can be dissolved at a given water temperature. It is made by heating a saturated solution, adding more solute, then cooling the solution. This solution is unstable, and if agitated or a solute crystal is added, the excess solute will precipitate, which is recrystallize, forming a saturated solution once again. How can we classify a solution using a solubility curve? A solubility curve shows the solubility of a substance versus temperature. The substance is usually dissolved in 100 grams of water. The level of saturation can be determined based on the amount of solute dissolved and the temperature of the solution. Unsaturated solutions are points below the curve. Saturated solutions are points that's found along the line of the curve, while supersaturated solutions are points found above the line of the curve. In this example, we are asked to determine the solution form, the type of solution form when 100 grams of NaNO3 is dissolved in 100 grams of water at 60 degrees Celsius. The first step is to determine the temperature on the x-axis and go up the temperature line. Next is to locate the mass on the y-axis and go across to the right. Finally, locate the point of intersection and describe the level of saturation. Here, the point is well below the curve of NaNO3, therefore it is unsaturated. How can we distinguish between solubility curves of solid and gaseous solutes? Solid solutes, such as NaNO3, have curves with positive slopes. The solubility of solids increase as the temperature increases. Gaseous solutes, such as NH3, have curves with negative slopes. The solubility of gases decrease as the temperature increases. What is the solute required to form a saturated solution in 100 grams of water? Example, determine the mass of KNO3 needed to make a saturated solution in 100 grams of water at 60 degrees Celsius. The first step is to locate temperature on the x-axis, 60 degrees. Then we move up the temperature line to intersect the line for KNO3. Next, we moved left from the point of intersection to read the mass of solute. Here it is 107 grams. A common misconception is to mix up the curve you're supposed to read. For example, instead of reading KNO3, you may read the data for KClO3. What is the solute required to form a saturated solution in different volumes of water? In example 3, we're asked to determine the mass of NH4Cl needed to form a saturated solution in 200 grams of water at 90 degrees Celsius. In 100 grams of water, a saturated solution is formed by 72 grams. In this case, we need to multiply it by 2 because we are asked to find how much would be in 200 grams of water. We obtain 144 grams. In example 4, we're asked to determine how much would it be in 300 grams of water. Here we would multiply by 3 to get 216 grams. And finally, in example 5, we're asked to find in 50 grams of water. Here we will divide by 2 to get 36 grams. What is the additional solute required to form a saturated solution at a specific temperature? In this example, an unsaturated solution of KClO3 contains 10 grams of salt and 100 grams of water at 50 degrees Celsius. How many more grams are needed to make this a saturated solution? Here, we need to determine the solute needed to make a saturated solution at 50 grams. It's determined to be 22 grams. Next, we have to subtract the amount of solute present already in the solution from the saturated mass. Here, we obtain 12 grams. What is the mass of solute that will recrystallize after the solution is cooled? When a saturated solution is cooled to a lower temperature, a smaller amount of solute will be soluble. As a result, the ions in the solute will recrystallize and precipitate. The precipitate is equal to the saturation mass at a higher temperature subtracted by the saturation mass at a lower temperature. In this example, a saturated solution of KNO3 at 60 degrees is cooled to 10 degrees. How much KNO3 will precipitate? First, we determine the amount of solute needed to make a saturated solution at 60 degrees. Next, we determine the amount of solute needed to make a saturated solution at 10 degrees. Then we subtract the two. 108 grams subtracted by 22 grams is 83 grams.